Hello and welcome back. What we're going to do this time is the last time you're going to see this kisser in front of you here. This is module 16, and we're going to do a recap of the whole thing. So this is going to take a while. So let's get to it. All this stuff out there, it always pops up and get started. First thing we're going to do, and this goes what it's supposed to be, is acknowledge this. This material, this entire course is taken from this book, Risk Management Tools for Safety Professionals by Bruce K. Lyon and George Popov. And it's available from the American Society of Safety Professionals. And all this information here in the book is based on the ISO 31000, which is mostly for enterprise risk management, which is like the whole company, ISO Guide 73, vocabulary for risk management, ISO 31010 risk management techniques, and ANSI 2590.3 prevention through design, PTD. And that is the one that's more closely aligned with the rules of an environmental, healthy, and safety manager. Let's do one definition over again. Stakeholder, because it's used a lot in here. Stakeholder is a person or organization that can be affected by or perceive themselves to be affected by a decision or activity. So that's a lot of people. It could be a lot of people. All right, this risk management process consists of these steps, and I'm going to show the same slide at the beginning of each step with the step that we're on highlighted, like this one right here. This one is called establish the context. That's the first step. This is the goals, what to use, etc. So we will set the purpose and scope of the risk management process and define the criteria with which will be assessed, such as the goal of the process. What specific jobs are we going to do or tasks are going to be covered in this thing? We're going to do the whole company. We're going to do Department A, whatever. Which risk matrix will be used? We're going to use throughout this course of 5x5, but there's thousands of risk matrices out there, but we got to determine which one we're going to use here. Will a prevention effectiveness factor be included? Sometimes there is a risk that has a pretty easily method of the effectiveness prevention is pretty high factor. So that will be included, could be included in there. Detection of failure factor. This is a risk that's very easily detected. It might be a high risk, but if it's very easily detected and can be stopped quickly, that could be a factor too. Those two aren't always used in everyone, and I've never seen them used, but they could be. Who will participate in the process? Safety professionals, machine operators, supervisors, outside consultants, any of these, all of these. It depends on what the scope of it is. And then the next step, that's pretty easy, establishing the context. Now we're going to go to risk identification, finding, recognizing, and recording hazards. A hazard is the potential for harm, pretty simple. A hazard analysis is the process that commences with the identification of hazards and proceeds into an estimate of the severity of harm or damage that could result if an incident or exposure occurs. Commences, which means begins with the identification of a hazard. So that's where we're at right now. First step, got to identify hazards, because if you don't, guess what? You can't do anything about it. A risk is an estimate of the probability of a hazard-related incident or exposure occurring and the severity of harm or damage that could result. Identification of hazards is the most important step in this entire risk management, risk assessment thing. Again, if you don't know that there's a hazard there, you can't do anything about it. The existence of a hazard alone does not necessarily translate to a risk. There also must be exposure to a hazard. For example, an unguarded chain and sprocket that's 20 feet above the floor working surface is definitely a hazard. But since it's out of reach of everybody, there's very little risk. But if it was 3 feet from the floor, it would be a huge risk to all who would be near. So again, exposure is a large part of risk. There could be something there, again, it's a risk. Nobody around it, not much exposure, not much risk. Hazards may be acute in nature, causing immediate harm, or chronic, causing harm from a prolonged or repeated exposure. This is the same as anything else that's acute illnesses, acute injuries, immediately, and chronic is long time. So hazards, but the same way. Basic causes of hazards may include machinery, design, selection, condition, use, and maintenance of machinery. If a machine isn't maintained properly, it could become a hazard. Humans, oh yeah, they're a big hazard, aren't they? Actions, inactions, knowledge, skill, capability, attention, interaction, communication. Management can be a hazard. right? Direction, supervision, enforcement, communications. Not that they're going to be a hazard, but they can cause hazards. If there are existing controls in place, they should be identified and analyzed, including a description of their dang function, effectiveness, and reliability. This means if you've already got some kind of controls in place, right? Chances are if you've got a piece of equipment that already has guard on it. The anticipated or reasonably foreseen consequences of a hazard should be identified. The subject of its impact, and one thing I like about that 5x5 matrix, it kind of gives you an impact for people, property, and environment, should be identified. A general description of types of consequences associated with hazards is needed to conduct a risk assessment. Hazard identification methods can be simple or complex, but in general industry, they're usually quite simple. Occupational health and safety inspections, audits, checklists. So that again, review of OSHA logs and our workers' compensation claims, interviews, or just plain talking with employees, and surveys are common. There are other much more involved methods that can be looked into if needed. A review of previous audits, codes, regulations, consensus standards may also be used. All right, now we're to the next step, risk analysis. Understand the consequences, probabilities, and existing controls. For those hazards and risks that have been identified, an understanding of the potential risk levels they present is determined during the risk analysis phase. Risk analysis includes the estimation of risk, which takes the causes and sources of risk into consideration, as well as the severity and likelihood of consequences. We've heard severity and likelihood quite a bit in this course. Risk analysis follows a sequence of action: determine effectiveness and reliability of controls, analyze the nature and magnitude of the consequences, analyze the likelihood, and then you can measure the risk. Determine effectiveness and reliability of existing controls. Do the controls reduce and maintain risk levels to an acceptable level? Are they acting as intended? Can the effectiveness of controls be tested and demonstrated? For instance, if you have a light curtain, can you stick something in it and see if it works? Are they easily bypassed? Somebody can easily disconnect it and just go around it. I've seen that happen quite a bit. Analyze the nature and magnitude of consequences. The types of consequences an event can have and their potential severity are determined. And an event may have more than one consequence. Analyze the likelihood. Likelihood of occurrence can be determined by three common methods: historical data view, if there's sufficient data available, which there usually isn't; predictive analysis, and expert opinion. Measure the risk, and that's usually the risk matrix is the most common way to measure risk. Define initial risk by using the risk matrix established as part of the risk criteria. By plotting the combined severity level and occurrence probability level, a risk score is determined that provides a visual representation of where risks are ranked to help decision makers manage risks. Because obviously you want to look at the most severe risks, or the highest risks first. Select and implement risk reduction methods. Select control measures from where? Our little hierarchy of controls. Assess residual risk. Following the addition of any controls, a second risk analysis is performed to determine residual risk level. Residual risk is defined as a risk remaining after risk reduction measures have been taken. So you do something, you put controls in, and you measure that. Then you measure the risk beforehand, you put in your controls, and then you measure the risk afterwards. And that's called the residual risk. There are many hazard and risk analysis methods. The simplest one that provides necessary information should be used. Assessing risk presented by identified hazards is key to risk management. It provides risk-based information so decision makers so that the most appropriate risk treatments can be selected to achieve an acceptable risk level. Hazard risk analysis steps are thus: develop a plan, scope, purpose, personnel, resources, budget, timeline, methods, etc. Responsibilities, the roles, responsibilities, and line of communication within the organization. Who's going to do it? Who's going to be responsible for it? Analyze hazards, exposures, and potential failure modes. I'm going to backtrack a little bit on this. Responsibilities. That's a big word, and it's a big word in life, and it's a big word in business. What businesses are looking for is somebody that will take responsibility for something. Don't ever forget that throughout your career. You can analyze hazards, exposures, and potential failure modes. Analyze existing controls. At this point, the hazard analyze severity of consequences. At this point, the hazard analysis has been completed, and then now we're going to do the risk analysis, and that is analyze and estimate likelihood. Likelihood is a general term that can be expressed as a frequency or probability of the future occurrence of the consequence scenario. Frequency is based on a rate measure and requires a denominator, such as time, number of tasks or products produced, or other measure during the life cycle of a system, process, or product. So frequency is something like miles per hour, units per minute, automobiles produced per day, whatever. Probability is an expression of the chance or odds of something occurring and is a pure number, such as 1 in 100, which is also 100 or 0.01. Same thing. Estimate the risk level, estimate the risk level. Once severity and likelihood risk levels are estimated, they are combined according to the selected risk scoring formula to derive a risk score level. And that's where our risk matrix comes in. Now, the next step, after we've done the establish the context, identification, and analysis, it's risk evaluation, comparing levels of risk and considering additional controls. Risk evaluation is the act of reviewing the information developed from the hazard identification and risk analysis and comparing that risk level against the organization's established risk criteria to determine acceptability, as well as ranking and prioritizing risks and determining whether the estimated risk is acceptable or risk reduction measures are required. Methods for defining risk criteria can range from simple 2 risk categories, which are simply those that require treatment and those that do not require treatment, to more complex methods that use multiple risk levels with graduated degrees of actions. And the graduated degrees of action is what that 5x5 matrix is going to do. Now, ISO 31010 presents a simple concept dividing risk into 3 levels used in evaluating risk. The 1 level, or the highest risk level, will be unacceptable. Immediate action is required. Operation not permissible except in rare and extraordinary circumstances. Usually, the operation is immediately stopped until the risk is at least reduced to an acceptable level. And then marginal, that's in the middle, where the cost and benefit of further risk treatment are evaluated before continuing. And acceptable, where the risk level is considered negligible and requires no further treatment. That's the 3 levels that are in that ISO standard we mentioned. Risk matrices. A risk matrix uses likelihood and severity to establish a number, sometimes a letter, but usually a number, indicating risk level, a very common method and one is which used extensively in this course. That's our good old risk matrix. Now, you can see, the ISO one had just 3 levels, and this one we have 4 levels. Very high risk, the very dark red numbers, or blocks rather, all the numbers are black. And high risk, 10 to 14, that's the bright red. Moderate risk is the yellow, or 5 to 9, and low risk is green. And usually those colors also fall within the same areas, as far as the highest risk being red, the lowest being green, which makes a lot of sense. Compared with the ISO one with just 3, which was what unacceptable, mediocre, and acceptable. This gives you 2 intermediate ranges. It might help you take the ones that are maybe a little bit higher risk and address those first. Note that even though it was mentioned earlier, ISO 3110 presented the concept between 3 levels: unacceptable, marginal, acceptable. This 5x5 matrix will return 4 levels. And they're very high, moderate, and low. High, moderate, and low, not really a significant difference though. Very high, moderate, low. That's 4. Again, that's not really a significant difference, but it just gives you maybe a little bit more information on those mediocre risks. Like I said, that the high ones and low ones, they're usually pretty easy to figure out, because the high ones are going to get your attention right away. The 20s, 25s, the 1s and 2s you're probably just going to go ahead and let those stand as they are. So it's the ones in the middle, the ones that require a little more thought. Now, the next step in this risk management process is risk treatment. Select the risk reduction methods or controls to use. Risk treatment involves the selection and application of risk reduction methods for a risk that is judged to be unacceptable. It is the end result of the risk assessment process. The term hazard or risk control, prevention, reduction, protection, and mitigation are all used to refer to risk treatment and are frequently used interchangeably by safety professionals. But let's look at each one a little bit closer. Mitigation is the act of reducing the severity of or seriousness of something. Mitigation is used to reduce risk, but does not include prevention of an event. Risk protection is the act of protecting, shielding, covering, or keeping an asset from harm. An example is an automatic fire suppression system in a building. Insurance is a form of risk transfer, is also considered a protection measure. Risk prevention is the act of keeping something that would cause risk from occurring. Example is a pressure relief valve on an enclosed tank to prevent overpressurization, and which is a result in a potential explosion. And risk control is a more encompassing term, meaning to manage risk by reducing likelihood and severity of an exposure. Risk reduction, like risk control, seeks to reduce the likelihood and severity of an unwanted risk. All these terms address elements of risk treatment, and often a combination of them are used. Recognized and generally accepted good engineering practices. Come across a list a lot in OSHA, and then particularly in process safety management. And it was introduced by OSHA in 29 CFR 29.1910.119, which is the process safety management standard, which requires all equipment in PSM covered processes comply with what it states. It allows employers to select the RAGA they apply in their covered processes. When the design codes, standards, or practices used in the design and construction of existing equipment are no longer in general use, the employer must determine and document that the equipment is designed, maintained, inspected, tested, and operating in a safe manner. Now, there's a lot of equipment out there that can be pretty old. And that, again, that's when that middle part, design codes, standards, or practices are used in the design and construction of existing equipment are no longer in general use. Sometimes you have a piece of equipment and you don't even know how old it is, and you don't even have a manual on it. That's where RAGA comes in. Risk treatment options, identifying risk treatment options. The risk assessment team or decision makers must determine the options available and their degree of risk reduction, their reliability, and the cost of implementing them and maintaining them. They should consider both internal and external sources. Some internal sources would be occupational health and safety professionals, experienced stakeholders. Now, they're saying experienced stakeholders. That means, people that were experienced with whatever it is you're dealing with. Operators familiar with the hazard and how control measures would impact them. I can't stress enough how important it is to have the people that operate the equipment or the process be involved in risk management and really everything involved with safety. They're going to know about this stuff a lot more than you ever going to know. And you get them on your side, they can be a big help, and then you're going to be a big help to them by keeping them safe. Affected workers' knowledge in the operation, equipment, and process. Sometimes the workers also not just the operators, which are usually, when they say operators and workers, usually on a larger piece of equipment, you have the one person that's called the operator. It might be more than one, and they basically do what it said. They kind of operate it, and then they might have people working on it that are workers. They're affected workers, but they're not really operating equipment. They might be unloading it, loading it, that type of thing. External sources, manufacturers' literature, such as operating and maintenance manuals. This is something else I'm going to stress a little bit. Manufacturers' literature is critical, and OSHA, even in process safety management, says that you should have to keep up your equipment in accordance with the manufacturer's recommendations. That's what that manufacturer's literature is. Manufacturer's agent or representatives. This can vary. Sometimes their agent is just a salesperson. They can't help you at all. But frequently, their agent is somebody that can be a very valuable asset to you, not just in this risk treatment and risk management, but throughout your safety career, showing you how to operate it, how to train your people, etc. Sometimes they'll even train your people. If you're going to buy any fall protection equipment, the harnesses, they'll always come in and help you train. Or actually, they'll always come in and train your people for you. Of course, they're not going to come in, every week and train them, so you have to kind of schedule that. Industry best practices throughout your industry. You might know what other people are doing. Industry consensus standards. Again, those are standard within the industry that kind of everybody does this because we all agree within our industry that that's the right thing to do. NIOSH publications, OSHA regulations, benchmarking other organizations with similar equipment or processes. Benchmarking benchmarking is great if you can do it. You can visit other organizations, go to trade organizations within your industry, and safety people are generally pretty generous about sharing information, and subject matter experts too, whatever the subject matter is about a piece of equipment or a function or process. Sometimes you're an expert and that can help you too. Hierarchy of risk reduction strategies. Risk treatment selection should always be linked to the concept of the hierarchy of controls to reduce risk to an acceptable level. Hierarchy of controls really just stacks those controls in a common sense order from the best control, or the most effective, to the least effective. So if you're going to consider controls, you don't want to consider the least effective first. You want to consider the most effective first. And if that doesn't work, you'll work your way down. There are many permutations of this concept, but they frequently share some similarities, such as having the most effective and reliable option at the top, descending to the lowest level, which is usually PPE. The multicolored triangle with the descending categories of elimination, substitution, engineering controls, administrative controls, and PPE is very common. It's called NIOSH's Prevention Through Design Hierarchy of Controls model. And you may have seen this before. Yeah. And you know what? You're going to see this again and again and again. And that's good. You should know it. You should know that what each one of these do. You should know by heart that elimination physically removes the hazard, substitution replaces the hazard, engineering controls isolate people from the hazard, administrative controls change the way people work, and PPE protects the workers with personal protective equipment. And as you can see from the bar on the left, the most effective is at the top and the least effective is at the bottom. Now, this is ANSI Z10 hierarchy of controls model. And as you can see, it has elimination, substitution, engineering controls, warnings, administrative controls, and PPE. Some of them throw that fourth one in their warnings. I've always considered warning to be an administrative control. So backup alarms, alarm beepers, horns, those are all, in my opinion, administrative controls. But some people call them that. That's fine too. If you want to use that, that's okay. ANSI Z10 and others add a control agency between engineering controls and administrative controls called warnings, which I just talked about, which is considered an administrative control in the others. So the change is purely superficial. Now we've done all this other stuff. We've established a context. We've done risk identification, risk analysis, risk evaluation, risk treatment. Now we're going to do monitoring and reporting. Now remember, this module is just a recap, just the high points. So the detail was all the individual modules that had each one of these in there. Monitoring and reporting is following up to be sure results were achieved, keeping decision makers and stakeholders informed. How can we ascertain that the risk management efforts results are achieved and maintained? Like other aspects of business, risk management performance must be monitored, measured, and communicated to be properly managed. Again, like other aspects of business. So every aspect of business to a degree is, in varying degrees, is monitored, measured, and communicated. Part of monitoring risk management control result is control effectiveness. Assessing control effectiveness should include the following checks or tests. Controls well designed, determined through a qualified review of design criteria. In other words, you have a guard, does it pass the OSHA regulations? Is it attached to the machine? Does it have sharp edges or corners on it? Control exists and is operational, verified through visual inspection of the operation. And this is a good idea to do every once in a while. A piece of equipment with some controls on it, whether they're light curtains or e-stops or something like that. You ought to try them sometimes and make sure they work. Test them. You ought to be tested on a regular basis. Control is performing as intended, tested and observed in operation. Control is reliable, reviewed, and for potential deviations, failures, or bypasses. In other words, it has to be working all the time, and it's formed as tested. That's where it's easier with an engineering control to do that than it is with an excuse me, I felt that coming up. So you can see that control is performing as intended, tested and observed. It's easier to do with an engineering control than with an administrative control. I mean, how can you test and administrative control. Well, there are ways to do it. And one of them is observing people and make sure they're following their training, etc. You test them on it, you retrain them on it. Anyhow, there's a ways you can do it. Control is not creating other hazards. Assess for unintended effects, hazards or deviations that could lead to other hazards or risks. And it has to be sustainable. It means it has to stand up to the degree of ongoing maintenance, calibration, service, or other needs, and the frequency of those needs. If your control is causing the production to slow down or stop, then you might run into the problem of people not wanting to use that control, wanting to bypass it too. So the control has to be sustainable. Now we're going to talk about key performance indicators, KPIs. They're quantifiable measures used to gauge performance over time. Current performance is compared to a baseline and the target performance. Now, KPI is an acronym that hasn't been around for too long. I don't remember hearing it 10 years ago or so. So it's somebody's doctoral thesis, and they come up with something that makes them different from anybody else. It's a key performance indicator. But for instance, if you're in production and you know what your output is per hour or something like that, that's a KPI. Well, then now they're just calling it something different. So if you're in a production operation, you're getting so many widgets per hour, you know what your current performance is compared to your baseline, which is the minimum acceptable performance, and the target performance, which is probably up higher than what you're doing. Because once you've tried to achieve that target, guess what? The target gets moved up. But hopefully that over time you can reach that target too. But key performance indicators are just goals along the way, pretty much. They may include leading indicators such as annual evaluation of the assessment process improvements completed, number of stakeholders trained in risk assessment, number of risks identified prior to any incidents. I like the last one, number of risks identified. That's kind of a good one. I like that one because these have to be quantifiable. You know what that means? You got to put a number on them. It's not just a whole lot or some. You're going to say, okay, we did 12 of these, or 27 or whatever. You can't compare them unless you have something that's quantifiable. Lagging indicators mean they've already happened. Number of corrective actions completed. You've done an inspection, you come up with these things that need to be done, and how many of them do you do? Average number of days to complete corrective actions. That's a tough one because one can take up a lot of days. Incident rate. Incident rate means, workers' compensation claims are rating. The incident rate's the OSHA incident rate they're talking here. And that OSHA incident rate is the number of OSHA recordable accidents times 200,000 divided by the number of hours worked. 200,000 be roughly the number of hours of 100 workers in a year. It takes a 40-hour week times 50 weeks, giving you 2 weeks vacation. 2,000 times 100, 200,000, 100 people. That's your OSHA incident rate is roughly how many accidents per 100 people you're having. And they usually are in single digits. Hopefully they are. Workers' compensation claim or rating. You have a workers' compensation carrier unless you're exempted, like you're a government agency or something like that. But if you're in private business, you have to have workers' compensation in every state. You have two things in there: claims being the number of claims, and probably more importantly is the dollar of claims. 3 claims at $150 each, not a big deal. Hit 1 claim at $150,000 is a big deal. So, and also the dollar rating is usually a good indication of the severity of the claim. Obviously, if you have a workers' comp claim of $150, it wasn't too serious. They didn't get too seriously hurt. All workers' compensation carriers will come up with a rating for your company. And the rating determines in a large part what your premium is going to be. And so if your rating is below 100 or 100%, usually it's turned as a percentage, then if it's at 100%, you're going to pay this much as the average in your industry. If your rating is at 80%, then you're going to pay 80% of the premium of the average in your industry. So that's an important number for you and for upper management. They want to know that too. KPIs should be performance measures that be collected and monitored. Got to be able to get it right and monitored, of course, and not too complex to understand or interpret. They should be clearly defined and communicated to ensure they are understood and meaningful. Clearly defined. In other words, not again, not and again, quantitative. If you didn't do it, document it, you didn't do it. It's a common saying in the sphere of safety. You could train somebody 100 times. If you didn't document it, you didn't do it. The purpose of documents and records is to provide information about risks to decision makers and other stakeholders, provide a record and justification of decisions made, preserve the results of risk management efforts for future use and reference, enable verification of results, and provide an audit trail. As new information becomes available and the context changes, risk assessments should be updated and documented in accordance with the needs of the management process. A common tool used to document risk is a risk register, a spreadsheet-style document used to document the risk levels. It gives decision makers a quick and concise way of comparing risk. It can be used as a basis for risk performance management, used to monitor and measure risk performance. Assigned duties or actions for stakeholders are measured on a periodic basis and reported to management. This is an example of a risk register. And it gives, you can see, it gives a case number. One is all in the QC lab weld and the plasma cutter, and give you hazard numbers. And that the first digit corresponds to the case number, and that makes sense. So you know where they're at. The hazard, they're not too, pretty short definition of the hazard. And then they give me a current state risk level. And you can look at some of these they're all in a red or orange. And then additional controls that have been completed by the dates shown there, and give you the future state risk level. So by putting in those controls, they have taken the hazard from all orange and red down to orange and some yellow and actually some green. So you have like the way at the bottom, 3.4 hot surface with a 14.25. They put in additional controls. I don't know what they are. Got it down to a 2.1. That's pretty significant if you can do that. But this risk register is not what it's doing it. The risk register is just documenting it. That's all. But they help you document it. And I think I'd have more detail on this one, but this is just an example. You can put as much detail as you want. Documentation alone is not the purpose. The information must be effectively reported to decision makers and stakeholders. Factors to consider for reporting and communicating include who needs the information. Key decision makers and effective stakeholders should be identified. Who are these people? What information do they need? Specific information needed to enable decision makers or to make their decisions must be identified. Guess what? Decision makers have to make decisions. And to make decisions, guess you need information. How often is this information needed? Quarterly, annually, monthly, weekly? How is it reported? Written reports, executive summaries, bulletins, graphs and charts, verbal reports, emails. That has to be determined. Monitoring effectiveness. After all the previous steps have been completed, we still need to know how effective they were. The goal of monitoring effectiveness is to verify that the results of the decisions made agree with what the organization intended. If monitoring indicates the results are not acceptable or correctable, a new decision-making process must be considered. Again, this is just another reiteration of this definition of stakeholder. Person or organization that be affected by or perceive themselves to be affected by a decision or activity. So stakeholder is a pretty big definition, and there's a lot of stakeholders in most places. Stakeholders are critical throughout the process. They should provide input and feedback through each step of the process, be involved up front to determine key issues to consider, be asked to provide their views on how each step of the process is performed and suggestions for improvement, provide relevant information needed for assessments and information needed in the decision-making process, achieve buy-in for the final decisions. You want them to again, by achieving buy-in, they become part of the decision, and by doing so, they're going to embrace that decision more. Understand and agree on the work to be performed in each step of the process. Have a sense of ownership in the process, which will help ensure their support of the decisions that have been made. Risk treatment tracking. The purpose is to track and evaluate the performance of the actions taken to prevent or mitigate risks. A tracking system provides structure and documentation of monitoring and the status of risk treatment's performance. There's no standard format for risk treatment tracking. You're on your own. Some of the basic needs of a risk treatment tracking system might include identification number for tracking purposes, the location, what plant, department, etc., what equipment is our operation was involved, a hazard description, maybe the causes of it or effect of it, the priority level. Where do we get that from? The priority level, the risk matrix, right? Hazard risk treatment description, action required, responsible parties. And we used to use abbreviation PPR, that was primary person responsible. And that's an acronym that I found that's not used in here. How about that? That's important in these things. Somebody has to say, okay, you're going to do this. You're going to get it done. You're gonna, if you don't have to do it personally, maybe, but you're going to have to see that it gets done. That's how you get things done. Due date, completion date, verification of treatment effectiveness. Okay, you did this. Did it work? Let's verify that it worked. Or else we've wasted our time. It's not good. Monitoring of effectiveness at a future date. Who will do it? Comments such as failures, improvements, or changes needed. Risk treatment tracking is usually performed by a risk manager. For a very large organization with many risk treatments to track, a project timeline or Gantt chart may be used. Now we're going to talk about strategies for selecting, modifying, and combining risk management methods. The number of risk management methods and tools available is somewhat overwhelming. There's just a whole lot of them out there. Many methods are variations of a theme used in various industries or situations. Certain tools have specific applications or purposes, while others are more broadly applied. The three most well-known standards, ISO 31010, ANSI Z590-3, and ANSI Z10, list 35 different risk assessment methods. So in these three standards, 35, but only they agree on one of them. That tells you how this is not defined science yet. It's still out there. There's a lot of things you can do in risk management. These three can't even agree only on one thing, and that's checklist. The what-if checklist is a type of checklist. It's frequently used in process safety management. That's the one we looked at previously in this course, doing a process hazard analysis. To establish which of these methods is best for your situation, most safety professionals will have to do some research, but most probably use the one they're most familiar with, or they seek the guidance of a competent expert. If you're familiar with it, you know it, that's the one you probably want to use. A competent expert, there's nothing wrong with hiring a consultant. You could access the following documents, which are the basement for this information herein. Again, these are the ones I've already enumerated, and I'm not going to read them again. But after you do that, look at them, you might be even more confused than you are now. So where to go from here? There's no roadmap to follow in this endeavor, but here are some suggestions. Start with what you're familiar with, what you know. That might just work out just fine. Talk to others in your company about their experiences. Talk to others in your industry. If there's an industry safety organization, join it and participate in it. Safety professionals are usually willing to help other safety professionals, even if they're in competing companies in the same industry. If there is a local safety organization, join it and attend. They're a good place too. You can rub elbows with other safety professionals. That always helps. Join a national safety organization, such as the American Society of Safety Professionals, and attend chapter meetings if they have them in your area. Join the International Institute of Risk Management. There's other risk management institutions you can join also. Hire a consultant. There's nothing wrong with this. No one person can know everything about the field of safety. Your company's workers' compensation insurer may offer some help. They frequently have consultants available. At OK Foods, our workers' compensation insurer had a consultant in process safety management down in Houston, and she came up and spent, I don't know, a week with us, so maybe longer. I think it was 2 weeks, all at no cost because it was part of our policy. So we never turned down free help. As a safety professional, you will always be alert to not just hazards and unsafe acts, but opportunities to learn from whatever source you can find. You may finish this course, but you should never stop learning. Good luck in your career. That's it.